Greetings and welcome back to room 303 in freshman English, and we now turn to the Sally Ride text on page 466, 467, single room earth view. Before we get there though, I want to turn to page 464, 465 and point out that we have been in these units often comparing titles together, and they're paired up now, two titles. We've got the Sally Ride text, single room earth view, and we've got the Neil Postman text, the news. And about both of these at 2B, we're going to be working at the literary analysis topic of expository essay. Let's write that term down at 2B. Let's define it. A short piece of nonfiction that presents or exposes, you can see why it's called expository, information, discusses ideas, explains a process. So any kind of a how-to process would be expository. An essay writer may use a variety of techniques to introduce, develop ideas, and to draw connections between those ideas. Definitely want these three things written down. Description, obviously including imagery. Language that appeals to the senses. Figurative language, such as simile and metaphor. So we're going to see that. Comparison, contrast, similarities, differences between two or more ideas, people, events, things. And then finally, cause and effect, explaining the relationship between events, actions, or situations by showing how one can result from the other. And then we're back to the main idea or central idea under reading skill, that is to say, the thesis and then the supporting details of points of validation. Do you see this diagram, this cluster diagram at the bottom of 465? I want you to try and use this as you go through the reading of these two essays and see how it kind of helps you to be able to understand what's being said in the essays. The key thing, though, about expository and exposition, write this down, is that when we are reading and writing expository, we are not trying to argue a position. That is what we call persuasive writing. Expository writing can be subsumed within persuasive writing if we're simply writing in that part of our writing, exposing ideas, sharing facts, or whatever. But strict expository writing, we don't have an opinion or anything like that. We just simply share ideas as we go. All right, I'm on to page 466. Again, our guiding question is knowledge something different from wisdom or understanding? Notice your vocabulary here, and we'll see a couple of those words that maybe for you are new words, all right? Like the word extrapolating, for example, the last word on page 466. If you don't know these words, you obviously want to know them before you do the reading. We're going to meet Sally Ride. Tragically, her birth and death actually is not included totally in this text. Let's make sure we get them both. She is born in 1957. She dies in 2012 from pancreatic cancer, tragically, and a research ship was actually named after her, the Sally Ride. Let's talk a little bit about her from her biography information. Although best known as an astronaut, Sally Ride was also a talented athlete in her youth. She was a ranked player on the junior tennis circuit and considered turning professional before deciding to go to college instead. In 1978, Ride read a newspaper advertisement about NASA's search for astronauts. After extensive testing to be sure she had the right stuff, NASA chose her as one of 6 women and 25 men accepted from among 8,000 applicants. 5 years later, in 1983, she took her historic flight. Ride retired from NASA in 1987 and currently teaches physics, well, when this was written anyway. She taught physics at the University of California. She held 4 degrees, as it says at the bottom of the page, from Stanford University, including a master's degree and a doctorate PhD. So let's just put it in our notes right away. This is a woman of tremendous ability, energies, and accomplishments, not just academic accomplishments, but how many people can say they ever flew into outer space? And then more importantly, we came back to write about it. Let's share the background information on 467 quickly. She's the first American woman in space. On June 18th, write this down, June 18th, 1983, when she worked as a flight engineer and a mission specialist aboard the shuttle Challenger, Sally Ride became the first American woman in space. Her historic mission allowed her to experience what she recounts in single room earth view. Now, if we were to start at 3B, and we were to ask, if you could take a flight into outer space, would you? And then more interestingly, maybe in terms of the question, because that one seems to me, for most people, to be self-evident. Well, yeah, if I could do it, I would. How do you describe something no one else has ever seen? or few people have ever seen. How do you describe that? You know what I'm saying? Like, how do you come back from some kind of an amazing experience? This is a 3B question, we'll come back to it. How do you describe, you know what I mean? How do you put into words experiences that are kind of beyond words? She went out into outer space, and when she came back, this is the essay that she wrote. So I hope that gives you maybe a sense of it. Now again, I'm going to challenge you, especially while we're reading this expository essay. Really try and concentrate on following the language of the essay as you read along with our reader. All right, here we go. Enjoy the text by Sally Ride.
Single Room, Earth View by Sally Ride. Everyone I've met has a glittering, if vague, mental image of space travel. And naturally enough, people want to hear about it from an astronaut. How did it feel? What did it look like? Were you scared? Sometimes the questions come from reporters, their pens poised and their tape recorders silently reeling in the words. Sometimes it's wide-eyed 10-year-old girls who want answers. I find a way to answer all of them, but it's not easy. Imagine trying to describe an airplane ride to someone who has never flown. An articulate traveler could describe the sights, but would find it much harder to explain the difference in perspective provided by the new view from a greater distance, along with the feelings, impressions, and insights that go with the new perspective. And the difference is enormous. Spaceflight moves the traveler another giant step farther away. 8 1/2 thunderous minutes after launch, an astronaut is orbiting high above the Earth, suddenly able to watch typhoons form, volcanoes smolder, and meteors streak through the atmosphere below. While flying over the Hawaiian Islands, several astronauts have marveled that the islands look just as they do on a map. When people first hear that, they wonder what should be so surprising about Hawaii looking the way it does in the atlas. Yet, to the astronauts, it is an absolutely startling sensation. The islands really do look as if that part of the world has been carpeted with a big page torn out of Rand McNally, and all we can do is try to convey the surreal quality of that scene. In orbit, racing along at 5 miles per second, the space shuttle circles the Earth once every 90 minutes. I found that at this speed, unless I kept my nose pressed to the window, it was almost impossible to keep track of where we were at any given moment. The world below simply changes too fast. If I turned my concentration away for too long, even just to change film in a camera, I could miss an entire landmass. It's embarrassing to float up to a window, glance outside, and then have to ask a crewmate, "What continent is this?" We could see smoke rising from fires that dotted the entire east coast of Africa. And in the same orbit, only moments later, ice floes jostling for position in the Antarctic. We could see the Ganges River dumping its murky, sediment-laden water into the Indian Ocean, and watch ominous hurricane clouds expanding and rising like biscuits in the oven of the Caribbean. Mountain ranges, volcanoes, and river deltas appeared in salt and flower relief, all leading me to assume the role of a novice geologist. In such moments, it was easy to imagine the dynamic upheavals that created jutting mountain ranges and the internal wrenchings that created rifts and seas. I also became an instant believer in plate tectonics. India really is crashing into Asia. And Saudi Arabia and Egypt really are pulling apart, making the Red Sea wider. Even though their respective motion is really no more than mere inches a year, the view from overhead makes theory come alive. Spectacular as the view is from 200 miles up, the Earth is not the awe-inspiring blue marble made famous by the photos from the moon. From space shuttle height, we can't see the entire globe at a glance. But we can look down the entire boot of Italy, or up the east coast of the United States, from Cape Hatteras to Cape Cod. The panoramic view inspires an appreciation for the scale of some of nature's phenomena. One day, as I scanned the sandy expanse of northern Africa, I couldn't find any of the familiar landmarks. colorful outcroppings of rock in Chad, irrigated patches of the Sahara. Then I realized they were obscured by a huge dust storm, a cloud of sand that enveloped the continent from Morocco to the Sudan. Since the space shuttle flies fairly low, at least by orbital standards, it's more than 22,000 miles lower than a typical TV satellite, we can make out both natural and man-made features in surprising detail. Familiar geographical features like San Francisco Bay, Long Island, and Lake Michigan are easy to recognize, as are many cities, bridges, and airports. The Great Wall of China is not the only man-made object visible from space. The signatures of civilization are usually seen in straight lines, bridges or runways, or sharp delineations, abrupt transitions from desert to irrigated land, as in California's Imperial Valley. A modern city like New York doesn't leap from the canvas of its surroundings, but its straight piers and concrete runways catch the eye, and around them the city materializes. I found Salina, Kansas, and pleased my in-laws who live there, by spotting its long runway amid the wheat fields near the city. Over Florida, I could see the launch pad where we had begun our trip, and the landing strip where we would eventually land. Some of civilization's more unfortunate effects on the environment are also evident from orbit. Oil slicks glisten on the surface of the Persian Gulf. Patches of pollution-damaged trees dot the forests of Central Europe. Some cities look out of focus, and their colors muted when viewed through a pollutant haze. Not surprisingly, the effects are more noticeable now than they were a decade ago. An astronaut who has flown in both Skylab and the Space Shuttle reported that the horizon didn't seem quite as sharp, or the colors quite as bright in 1983 as they had in 1973. Of course, informal observations by individual astronauts are one thing, but more precise measurements are continually being made from space. The Space Shuttle has carried infrared film to document damage to citrus trees in Florida and in rainforests along the Amazon. It has carried even more sophisticated sensors in the payload bay. Here is one example. Sensors used to measure atmospheric carbon monoxide levels, allowing scientists to study the environmental effects of city emissions and land-clearing fires. Most of the Earth's surface is covered with water, and at first glance it all looks the same, blue. But with the right lighting conditions and a couple of orbits of practice, it's possible to make out the intricate patterns in the oceans. Eddies and spirals become visible because of the subtle differences in watercolor or reflectivity. Observations and photographs by astronauts have contributed significantly to the understanding of ocean dynamics, and some of the more intriguing discoveries prompted the National Aeronautics and Space Administration to fly an oceanographic observer for the express purpose of studying the ocean from orbit. Scientists' understanding of the energy balance in the oceans has increased significantly as a result of the discoveries of circular and spiral eddies tens of kilometers in diameter, of standing waves hundreds of kilometers long, and of spiral eddies that sometimes trail into one another for thousands of kilometers. If a scientist wants to study features on this scale, it's much easier from an orbiting vehicle than from the vantage point of a boat. Believe it or not, an astronaut can also see the wakes of large ships and the contrails of airplanes. The sun angle has to be just right, but when the lighting conditions are perfect, you can follow otherwise invisible oil tankers on the Persian Gulf and trace major shipping lanes through the Mediterranean Sea. Similarly, when atmospheric conditions allow contrail formation, the 1,000-mile-long condensation trails let astronauts trace the major air routes across the northern Pacific Ocean. Part of every orbit takes us to the dark side of the planet. In space, night is very, very black. But that doesn't mean there's nothing to look at. The lights of cities sparkle. On nights when there was no moon, it was difficult for me to tell the Earth from the sky. The twinkling lights could be stars, or they could be small cities. On one nighttime pass from Cuba to Nova Scotia, the entire east coast of the United States appeared in twinkling outline. When the moon is full, it casts an eerie light on the earth. In its light, we see ghostly clouds and bright reflections on the water. One night, the Mississippi River flashed into view, and because of our viewing angle and orbital path, the reflected moonlight seemed to flow downstream, as if Huck Finn had tied a candle to his raft. Of all the sights from orbit, the most spectacular may be the magnificent displays of lightning that ignite the clouds at night. On Earth, we see lightning from below the clouds. In orbit, we see it from above. Bolts of lightning are diffused by the clouds into bursting balls of light. Sometimes, when a storm extends hundreds of miles, it looks like a transcontinental brigade is tossing fireworks from cloud to cloud. As the shuttle races the sun around the Earth, we pass from day to night and back again during a single orbit, hurtling into darkness, then bursting into daylight. The sun's appearance unleashes spectacular blue and orange bands along the horizon, a clockwork miracle that astronauts witness every 90 minutes. But I really can't describe a sunrise in orbit. The drama set against the black backdrop of space and the magic of the materializing colors can't be captured in an astronomer's equations or in astronauts' photographs. I once heard someone, not an astronaut, suggest that it's possible to imagine what spaceflight is like by simply extrapolating from the sensations you experience on an airplane. All you have to do, he said, is mentally raise the airplane 200 miles, mentally eliminate the air noise and the turbulence, and you get an accurate mental picture of a trip in the space shuttle. Not true. And while it's natural to try to liken spaceflight to familiar experiences, it can't be brought down to earth, not in the final sense. The environment is different. The perspective is different. Part of the fascination with space travel is the element of the unknown, the conviction that it's different from earthbound experiences. And it is.
All right, let's turn now to study how this expository essay does its job. Let's put it in our notes for two reasons we want to do this. One, we obviously want to be informed. Two, we want to be better at doing this kind of expository writing ourselves. Let's go ahead and say it out loud. Many students believe expository writing or how-to writing or explaining information is boring writing. I think that here's a classic example of how it doesn't have to be boring at all. Of course, hello, subject matter helps. Number two, let's write this one down. The challenge of this essay is to say in language what cannot be said or really expressed in language. Why? Because we try to explain new things through metaphor and simile, comparisons. Let me compare something you already know. This will sound a lot like our learning theory in 303. Let me compare something you already know to something you don't know. For example, if you've ever flown in an airplane, well, flying in outer space is similar. That was the assumption. And our speaker here will say, no, 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 no. One way to say this is, sometimes when you're describing this kind of thing, it's beyond words or translinguistic. You can't explain it. It defies explanation. And yet notice, she goes ahead and tries it anyway. One of the reasons, going back to the beginning of the essay on page 469, is that it's always going to be the question. Think about the last time, 3B observation. Think about the last time you traveled somewhere. Think about the last time you had an experience, and when you came back, might have been your pal, might have been a complete and total stranger, asked you, what was it like? Describe to me what it's like. Notice at the beginning of the essay, though, she says, describing flying in space is kind of like describing to somebody who's never flown on an airplane what it's like to fly in an airplane, right? Notice if somebody tries to describe something to you that you haven't experienced. So, for example, your friend goes to, I don't know, let's just say Vienna, the great city of music, and you come back, and your friend who's never been there says, tell me what it was like, explain it to me. You start trying immediately to describe it by something, well, it's kind of like, and it's kind of, right? This is the challenge. So let's pay attention to the ways in which she will try to explain what it is she's seeing, right? Even though we ourselves have never actually experienced it. Notice she says it on page 469. It's not easy, because she will say, imagine something so hard to explain, especially when you're traveling at every 8.5 minutes into space, right? As she points out, right? Suddenly, she says, 8.5 thunderous minutes after launch, there you are. At 8.5 minutes, you go from the ground to being in outer space and looking at the ground. I mean, that in and of itself is a compelling idea. Whoa! In 8.5 minutes, which is basically 2 songs on your playlist, roughly, right? 2 songs on your playlist, you go from being on the ground to being out in outer space looking back at the earth. Kind of a mind freak already. By the way, notice, she uses maybe simple observations like that one to try and give you a sense of, and then she's going to use this word on page 470. In many ways, this is the word of the entire essay, so write it down on page 470. The word is, it's a vocab word as well, surreal. Surreal. Now, of course, this word is a fascinating word. It's kind of dream-like. We use this word often when we're talking about, for example, the great writer named Kafka. When we talk about a story by Kafka, we talk about surreal. It means beyond explanation or dream-like. You're trying to explain it, but you just don't have good words to explain it, right? So she uses a few stats on page 4, statistics on page 470, right? She tells us that the shuttle circles the Earth once every 90 minutes. So there's an interesting idea. Every hour and a half, she goes around the Earth one more time. Everything changes too fast, and she ends up ironically asking, what continent are we looking at right now? She begins to describe what it is that she can see, or what they can see, right? She talks about plate tectonics making sense, and of course you can jump over to page 472 quickly to see your science connection here, and the idea of plate tectonics, the idea that when you see the world from that perspective, you begin to get a sense of how it all